We'll be looking at this problem today about probability and using graphing calculators. So Emlyn plays many games of basketball for a school team. The number of minutes he plays in each game follows a normal distribution with mean m minutes. In any game, there's a 30% chance he'll play less than 13.6 minutes. In any game, there's a 70% chance he'll play less than 17.8 minutes. The standard deviation of the number of minutes Emlyn plays in any game is 4. 50% chance Emlyn plays less than X minutes in a game, and Emlyn will play in 2 basketball games today. So we want to sketch a diagram to represent this information. We know that this is a normal distribution, so we can draw a normal distribution plot that looks something like this. And we know that there are m, which is the mean, which would be right in the middle of our normal distribution. The other way we can do it is we can have 13.6 right at our 30% mark, or we can put a 17.8 right at our 70% mark. If we want to show that m is equal to 15.7, we can look at 30% and 70%. Since this is a normal distribution, the distance between 30% to 50% is the same as the distance from 50% to 70%. So we can just take the average of 30% and 70%, which is 13.6 plus 17.8 divided by 2. And if we put that into our calculator, we have 13.6 plus 17.8 all divided by 2, and we'll get 15.7. There we go. Part C says find the probability that Emlyn plays between 13 minutes and 18 minutes in a game. So for this one, we will have to draw our probability plot. So we'll press y equals on our graphing calculator to get our plot equations. And after we do that, we'll press our second and look for the distribution button. And we are going to select the first one, which is normal PDF, normal probability distribution function. So our x value will be our variable x. Our mu, or our mean, is 15.7 because this is our mean. And our standard deviation says 4. So we're going to put 4 for our standard deviation. We'll paste this into our y1 and we'll graph it. Right now, it doesn't look very good because we have to set our window. So our x min we'll set to 0 and our x max we'll set to maybe around 30. And we'll click graph again, still not so good. So we'll click zoom and we will go all the way down to zoom fit. And we'll click enter and we'll get a nice normal distribution plot like this. So now that we have our plot, we want to find the probability that Emlyn plays between 13 minutes and 18 minutes in a game. Now we can go back to our distribution area and look for the draw function. So instead of distribution, we're going to go right to our draw and we're going to click the first one, shade normal distribution. Our lower one will be 13 minutes and our upper will be 18 minutes because we're looking for in between 13 minutes and 18 minutes. And our mean is the same, 15.7, and our standard deviation is 4. We'll keep the color blue and we'll draw it on. So this is our probability that we'll have between 13 minutes and 18 minutes. And you can see the area is 0.46752. So our probability is 46.8% chance. And the part 2 of this question says, find the probability that Emlyn plays more than 20 minutes in a game. So for this one, we can do the same thing. We'll go back to distribution and draw. We'll shade our normal distribution. Our lower this time will be 20 minutes. And our upper distribution will be infinity because we can put as much as we want. But for the calculator, the maximum is 10 to the 99. So we'll just put 10 to the 99. And 15.7 is our mean. Standard deviation is 4. This time, let's make it green. And we'll draw this on. And here we can see our area is 0.14119. So our probability that Emlyn plays more than 20 minutes is 14.1% chance. Okay. Part D says find the value of x. So what is x? Earlier they said that there's a 60% chance that Emlyn plays less than x minutes in a game. So we have to figure out how many minutes is a 60% chance that Emlyn plays less than. So to find this, let's clear our drawing by pressing draw. And we're clearing the drawing and go back to our graph. To find how much that is the 60% mark, we can just go back to distribution. Instead of normal probability distribution function, we'll go to number 3, which is inverse norm. And for this, we'll select our 60%, or 0.6. Our second argument will be 15.7, which is our mean. And our third argument is the standard deviation, which is 4. Once we put this in, we'll click enter. And now we know that at the 60% mark, it is 16.7 minutes. Okay. Finally, this last part says find the probability he plays between 13 minutes and 18 minutes in one game and more than 20 minutes in the other game. So for this one, let me make more room on here. So for this one, we have 2 options. The first game, which is 13 minutes and 18 minutes, will be 46.8% or 0.468. The other option is 20 minutes in the first game, more than 20 minutes in the first game, which is 0.141, right? This other option is the first game is 0.141, more than 20 minutes. And the second game is 0.468, which is between 13 minutes and 18 minutes. So we have 2 options. We have either the first game is between 13 and 18 minutes, and the second game is more than 20 minutes. And our second option is if the first game is more than 20 minutes, and the second game is between 13 minutes and 18 minutes. So once we put this into our calculator, we have 0.468 times 0.141 plus 0.141 times 0.468, and we'll get a 13.2% chance. We'll finish this next part of this problem in the next part.